Hello. Today I would like to present to you 12207 target question number 5. A real number r is randomly and uniformly selected from the interval -1 to 1. The probability that the line with slope r passing through the point 0, r also passes through a point with x coordinate r and y coordinate between -1 and 1 is a plus root b over c, where a, b, and c are integers such that the greatest common divisor, ac, is 1, and b is not divisible by the square of any prime, and we must compute the sum a plus b plus c. So we're given that a line with slope equal to r with 2 points that have slope of r, 0, r, and r, y, where y is between -1 and 1. We'll assume that's an inclusive. If it were exclusive, it wouldn't affect the probability at all. We can use the slope formula. Y minus r change in y over r minus 0 change in x. That's equal to r. So that's our slope of that line, parameterized by y being between -1 and 1. Multiply by r on both sides because r minus 0 is r. You get y minus r is r squared. So y equals r squared plus r. We know that y is between -1 and 1, so we can just plug that in. We see that -1 and 1 are the two endpoints between r squared plus r. So r squared plus r is between -1 and 1. Just add 1 to everywhere to get r squared plus r plus 1 is between 0 and 2. Now, if we complete the square on this quadratic, we see that this square term is always greater than or equal to 0, and 3/4 is already greater than 0. So r squared plus r plus 1 is already greater than or equal to 0. This is true, or always true, for r between -1 and 1. So we just need to focus on the right-hand inequality. R squared plus r plus 1 is less than or equal to 2. We see that r squared plus r minus 1 is less than or equal to 0. And we need to solve for its roots so we can make some bounds. We see that r is going to be equal to -1 plus or minus 1 minus 4 times 1 times -1 over 2 to give you -1 plus or minus square root of 5 over 2. That's the places where this quadratic equals 0. So we need to make a little sign chart to see what range of values of r satisfy this inequality, and that will give us our numerator for our probability. Something simple, -1 minus root 5 over 2, that's the negative root. And then -1 plus root 5 over 2, that's your positive root. So we know that, let's test the value 0 here. That's in between these two roots. So we plug in 0, we get a negative number. And that's the values in between these two roots satisfy this inequality right here. You could test the rest and see that anything less than the negative root and anything greater than the positive root will all give you a positive value when you plug it in that particular value of r in the quadratic. So we see that the solutions, these are the solutions for r. But we're given in the original premise that r needs to be between -1 and 1. And if you plug this into this calculator or do a quick approximation that square root of 5 is greater than the square root of 4, this is actually less than -1. So this is actually our desired inequality. So that's our actual bound for r, because -1 minus root 5 all over 2 is less than -1. So we have to exclude those values between -1 and -1 minus root 5 over 2, because that's out of our range for r given in the problem. So we're done. We just need to find the length of this interval. That's root 5 minus 1 over 2 minus -1. And then we need to divide by the actual length of the interval r given. That's 1 minus -1. Simplifying, we get root 5 plus 1 over 2 all over 2. And so I'll write the answer here. P is root 5 plus 1 over 4. Or I should put it 1 plus square root of 5 over 4. to explicitly show the form that a equals 1, b equals 5, and c equals 4. B is not divisible by square of any prime, and 1 for the greatest common divisor gives you 1. So a plus b plus c equals 1 plus 5 plus 4. This will give you the final answer of 10. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.